Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello and welcome to the latest episode of Lunch with Tech Leaders. My name is Brendan Theide. I'm a senior site reliability engineer at Filevine, and I'm your host for today. Joining me are software and data consultant Tom Kowalski.
Hello.
And also today we have Matt McLane, DevOps engineer lead at Doc Network. Thank you for joining us, Matt.
Hey, everybody.
And in this episode, we're going to discuss how Docker can be used during development in order to give production-like environment locally, as well as some tips for getting the most out of that. And so to kick things off, Matt, would you mind describing some of the basics of Docker and container technology?
Sure. So I think of Docker as an evolution along the lines of virtual machines. So if you go in way back in the day, everything was on a mainframe, and then they broke the mainframe up into a client-server technology. And so when you wrote production code, it would be running on some server in some server room. And because servers were expensive, you'd have a lot of code running on that server, and sometimes they would play well and sometimes they wouldn't. Eventually we moved into virtual machines, and we were able to take that server and break it up into multiple servers. And that was great because we could isolate pieces of code that would conflict with each other, and so they were running on separate machines but use the same set of hardware. But it wasn't a perfect solution either, because, those virtual machines had full operating systems on them. And because of that, they would have full set of vulnerabilities, and they were heavier, and they took longer to build, and they took longer to spin up, and all of that stuff. So along that line, we get to containers. And what a container is, how I think of it, is it's a stripped down virtual machine that only has what is needed to run the code that lives in that container. It takes away the networking stack from that operating system, or all of the extra tools that you might not need, the UI part of it, and even some of the basic networking troubleshooting commands may not be in your container, because you want it to be as small as possible. And the reason for that is the smaller it is, the fewer vulnerabilities you might have, and the faster it'll spin up, and the faster it is to download. So that's what a container is. That's how I think about it. And the move towards containerization has really enabled whole new ways of building and designing solutions. Because what you end up getting is an artifact. That container image is an artifact that includes your code and all of the dependencies it takes to run that code, all bundled up into one, in a way, executable artifact. And so you don't have to, another user doesn't have to take and install your code and then install all the pieces that it takes to run your code. It's all right there, all bundled up. So that's kind of the goal, or that's kind of what containers are and how I see them fitting, if that makes sense. Am I missing anything?
I think that was a good introduction to it. Now you mentioned the leanness of the containers, and I think that's one of the things that gets discussed around the concept of bin packing. Is that something that you could describe the benefits of a little bit versus VMs?
Sure. So when you have a really small container, it uses a certain amount of RAM and a certain amount of CPU, and you can pack that stuff into servers so you can run many of these containers on one server because resources and all of that. And so by looking at like which containers are using the CPU at any given time, the system can pack those in as much as possible so you can have multiple threads running at once, and have it all bundled up. You know what I mean? So there are whole systems for doing that work, for scheduling the containers to run. And that's where you get into things like Kubernetes or what Mesos, I think, is the another one of them, that does that kind of scheduling and work for you.
Yeah, and I think that's one of the really powerful arguments for using containers is making better use of your resources you already have. You don't have to pay for a bunch of extra hardware necessarily to fit the same workloads, while at the same time you're able to avoid that dependency hell that you were talking about, where you have conflicting binaries, conflicting libraries, conflicting versions of things.
Well, and let me give an example of where we've seen improvements at right here at Duck Network. It used to be that they would run, they would use PM2 to run multiple threads of our application within the operating system. So you'd have a server and it would be running 4 threads, so 4 copies of our app, and then we would run multiple servers. So ultimately we would have like 16, let's say, and that would be 6 servers running 4 threads. The problem with that is that it's really hard to see what's going on any given thread and see where the logs fall through, and if one thread is failing or restarting, all that gets really hard to see. Once we took our containers and broke it up so there was 1 thread per container, it's really much easier to see this container failed. Here's the logs for that thread, and that's what it did, and that's where the problem was. Does that make sense? And then not only that, we don't spin them up and get 4 more. We can spin it up and get, 2 more or 3 more, depending on what the need. We get much more fine grain control.
Yeah, and that's a great point. You get that finer grain control about what type of capacity you want to leverage, and you can incrementally scale up or scale down. And you've talked a lot about, really good reasons for why these are a great tool for, deploying our workloads to the cloud or to even our local infrastructure. But for developers, now we have Docker Desktop available on Mac and Linux and Windows. You don't even need the professional version of Windows anymore to get those things working. What are some of the reasons? I'm hoping a lot of them are obvious, but go ahead and go into some of the reasons why a developer would want to use Docker to run containers locally, the same as they're going to be run elsewhere.
Yeah. So for me, the big benefit I see there, when I mentioned earlier, was creating an artifact that is a bundle of everything that is needed to run that code. That's the same thing that happens on your local or local development environment as well, right? When we work as a team, if I'm going to go and update a dependency in the code, you need to also update that dependency. And so how do you do that, right? How do you coordinate all of those various versions? Now, I know that our programming tools have like lock files that we can commit into Git and all of that stuff, but maybe we haven't committed, and or maybe I'm not pushing on a branch, or maybe it's very fundamental, and having that version be in sync across the developers can be really important. And so I give it to you, and now you've got to go update it. And how do you update it? If it's all bundled in a container and I can push that container, you get everything all in one go. And your local development machine, it matters a lot less what's installed on there. So if my laptop were to die tomorrow, I wouldn't have to go figure out all of the various pieces I need to install in order to just run the code. And make sure that, and by the way, make sure that all of the various versions line up. Instead, I could just run a command and it'll pull that container down. And it's the same container that's going to run later on. That's really, really powerful. If you go and read on how development should happen in the DevOps, Bibles and such, they'll talk about moving things as far to the left as possible and getting problems to surface earlier and earlier in the development cycle. If I can get my developers to figure out that there's a problem with a dependency when they're still working on the code, that's way better than if we figure it out much later in the process. When we're about to deploy, right? We don't want to interrupt the deploy because of those kinds of problems. Having that all bundled together in a container, that's huge. It moves it all the way to the left. You know what I mean?
Yeah. Yeah, and that can definitely expose things a lot earlier. And like you said, it can also help with onboarding new developers, getting them up and running faster, or not even a new developer, but just an existing developer moving to a new machine or whatever.
Exactly. You move around. You can swap big things out, and then it's really easy to fall back to a previous version if something's not working, right? These are all the reasons we use version control. So all we're doing is all the container workflow is bundling that all up together into one artifact, and then it's a versioned artifact on top of that, right? So it's easy to branch that, to go left and right, but you don't have to compile it, if you will. It's already done.
Yeah, absolutely. And I'd like to bring Tom into the conversation here. I know, Tom, you mentioned not using Docker a ton for yourself. And so I'm curious, are there specific flows that you do or just the nature of the technologies you're focusing on that would make it less useful?
Yeah, so it goes right in line with what you guys were saying of that making it easier with those dependencies. I think it depends on the language that you're using, the runtime. There's instances where it's a lot more useful than others. I started off in Windows development and .NET development, and you basically just have that runtime and main library, right? That .NET library. This is the number. These are the libraries that you have. You may have some other dependencies, but it's usually not that much, and you don't have the it ran on my machine as much as you do with other languages and other runtimes. But recently, I've been doing a lot with Python development because you can have different virtual Python environments, but there's a lot of little gotchas here and there with it. And when working with Docker, it makes it a lot easier with working with my coworkers, because I can just share that image with them. Okay, this has everything that this app needs to get going. So yeah, that's how I've seen it a lot. So yeah, I feel like it depends on the language. And then for me, my journey is a lot of Windows development, and then didn't really need so much containers with that. But then once serverless came along, that kind of made us, that next abstraction, and I started using that more. But yeah, now I'm coming back in some of my development with Python. It's been a lot easier working with that with Docker.
Yeah, specifically Python and Ruby are two languages where when I am dealing with the runtime, I will almost always use a container, because there might be a very specific version that I need for one thing, but I don't need it for another thing, or I need a different version for a different thing. And so it's nice to have the container where I can just Docker pull, Docker run, get it done, get it out of there. And what makes that even cooler in my mind is how you have the development containers that you can access directly from some GitHub projects, where you can run the container right there in your browser and have the exact versions of everything and all the pieces ready to go.
Now, another place that this gets, another road you can go down here, if you will, is when you talk about microservices and having reliant services run on it, or that need to talk to each other, right? So an example would be like a Redis database that your application needs to talk to in order to get some information back or to store or whatever, right? I could have that Redis running locally. But then if I want to test something, like test upgrading it or test changing how I do, or, any of that stuff, I have to upgrade my local machine, and then falling back, I have to uninstall and reinstall, and even that simple thing gets to be a complicated thing, all because my application needs to talk to this other service. If you have that Redis running in a container, that becomes a lot easier, right? And when you start talking about more than one of these, right, 3, 4, 5 of these ancillary services that you're talking to, having each of them run in a container, because it can be really powerful as you can swap things in and out.
Yeah, and another thing that I've found useful with containers is, like, for my organization, they use Microsoft Intune to keep track of software running on Windows machines, right? And you get the nasty report saying all the things you have that are out of date. Well, rather than, running SQL Server Express on my Windows laptop, I can just run MS SQL in a container. And when I'm not using it, it's not running. And when I'm ready to use it again, I just Docker pull latest, and I've got, the upgraded version. I don't have to worry about having, out of compliance software running on my system in the background when I'm not using it.
Right, exactly.
And for working with multiple containers, kind of dependencies and such, I know you can install Kubernetes locally. Actually, Docker Desktop has its own Kubernetes engine that you can use. But do either of you have experience with Docker Compose and how that can help your inner loop for development?
So I've not gone down the road of Docker Compose personally because we are a Kubernetes shop, and so I use some form of Kubernetes locally when I need that kind of stuff.
Yeah, not so much either. Because if I'm using it, it's more for just like a one-off project here and there, and there's usually not too many dependencies, more automation things that I'm working with, at least right now.
Yeah,
so.
But I do know that, like, Docker Compose is how you can set up an environment so you can run multiple containers all connected to each other, right? So in that the example of the Redis cluster or multiple containers talking to each other, that's where you would use Docker Compose to connect that all together. Is that correct?
Yeah. So you can definitely, you can create networks within Docker Compose to be able to share connections between different containers. You can have your volumes predefined, things like that. It is a little bit simpler for people who maybe aren't used to dealing with Kubernetes.
Sure.
So, because, with Kubernetes, you're going to have to set up things like ingress and you might have different namespaces and network policy. Those types of things become simpler with Compose.
Yeah.
But I've definitely seen companies go multiple different ways, right? Where you have, like, the company I'm at now, you have a Docker Compose file. You've got your Compose YAML for developers to run locally to spin up multiple containers, but then there's also a separate Helm chart that kind of mirrors the same things, and that Helm chart is, just for deploying out to, EKS or wherever you're running. And then I've also seen it where you have virtual clusters using something like vCluster or, Loft technology to be able to send out your requests to a cluster that's running in the cloud, but you're connecting to it from your local, and it just feels like it's local.
My feel on how you make that decision is what your company looks like and who you have to run stuff, right? Mm-hmm. So if your developers aren't really getting into Kubernetes, either in development, a development environment or a QA or staging or any of that, if they're not interfacing with Kubernetes and you have a separate team doing all that for them, then Docker Compose might be a better fit for them to do stuff locally, but still have it all be containerized so that it's easier to hand off that container to the other team so that they can deploy it into the Kubernetes cluster. At Duck Network, our developers are all in Kubernetes, so we don't quite need that, right?
Yeah, so your
Yeah,
environment, your flow, your culture may dictate a little bit of which path you go down.
absolutely. That's what I'm saying. Yep.
Yeah. Yeah, but I think the same principles would still apply, right? The principles of having this, all your dependencies defined in one consistent place where you're not having to, manually install things after standing stuff up, things like that. The more of that you can avoid, the better. The more you can have things prepackaged, the better.
Right, exactly. Oh, and another benefit I just thought of is when we push that container up to a repository, it automatically scans for vulnerabilities and automatically scans for viruses and that kind of stuff, right? That's all done. And it's done with rules so that we can't deploy it to the next environment without it passing to some threshold, right? All of that's really powerful, right? When by the time it gets to production, we already know the security state of that container, of that runtime, of everything in it. And so it helps us from deploying something that has a vulnerability and then finding out about it after the fact.
Yeah. And that actually brings up another thing that I wanted to talk about a little bit was some of the tooling that you can get as part of Docker Desktop. It's kind of that very simple, you install the one thing and you get a lot of stuff. It has things built into it like Docker Scout that can do some of that vulnerability management, and it can try to show you where they're getting in within your containers. There's also tools around managing backups for local development. Are there any tools that you've used or things that you've heard recommended?
One of the things that we're more and more looking at are hardened containers or slimmed down containers. And the biggest reason for that, so there's a container that runs Ubuntu, right? It's a full operating system in there. And we can install our application in it and run it, and we get a container, and it's, a couple hundred meg, which isn't terrible, and on a, 10 gig network, right? But when you do that, there's a lot of extra stuff installed inside of that operating system, and when you scan it, you get a lot of vulnerabilities that it picks up. We could try to go fix all those vulnerabilities, or we can use a slimmed down container, a hardened container, and it has none, right? There's no vulnerabilities because they've ripped out all of the extra pieces that we're never going to use, right? I don't need Nano installed in my container all the time because my application doesn't need it to run it. And so looking at hardened containers is a big move that anybody can make. That's the first thing that jumps to mind.
Yeah. And I would say a couple of things for people to research if they're interested in that are Slim AI. They're a service that can provide these hardened containers, and you can get subscriptions to them, and they can scan your images and scale them down. And then also Wolfie as a base image. But yeah, definitely the less you have in your container to start with, the less opportunity there is for vulnerabilities.
Yep. Yeah, as far as tools go with containers, it's not complicated. A Docker file it's just a text file. So, we use VS Code and we write that out, and a make file to make the commands to build the container easier. That's kind of the level of technicality we have there. We do have a pre-commit hook that will run a scan before we push it up, or before we commit the code. So we do have that kind of stuff possible. And then everything else, we're pushing it to a code repository that automatically runs a virus scan, and then from there, our CI/CD pipeline kind of the deployment part picks up the containers as they get deployed, and that's kind of how that works.
Yeah, and you mentioned also kind kind of the way that things are built on top of each other. You mentioned Ubuntu as like a base layer for a lot of containers, and then, layers get added on top of that. And that layers concept is something that Docker uses, all the OCI, the Open Container Initiative containers use. And one thing that I think is confusing to people at first is that layers are always additive. So if you have a layer that has things in it, and in a later layer you delete those things, they're still there. All you've done is you've added the thing to, change the pointers at that file system level so that it doesn't look like it's there anymore. But if you look at the lower layers, it's still there.
Yeah, I'd call the Docker layers like advanced topics on Docker, right? Like you can go deep in optimizing your containers to make them super small and super lean and all that stuff, right? That's where that layer stuff gets in. Because you're right, if you start with a really big container and then you delete half of the stuff, it's not going to make it a smaller container necessarily, right? It's still going to be kind of big. But if you start with that little container and then you add on just what you need, you get a much tighter thing, which is great because then your system, every time every time you have a server that needs to pull that container, there's transfer time, there's transfer speed, and that can be, 20 seconds, right? Which for your app might not be a big deal, but when you're running 80 of these things, that time adds up, right? So if I can take that 20 seconds and scale it down so that it only downloads in 3, then it becomes a lot quicker. Everything goes much faster, and you can actually feel that, right?
Yeah.
So getting into how to optimize the containers and make them really tight and lean and all that there's some finesse there for sure.
Yeah, and I wouldn't necessarily recommend people start by trying to optimize and get the leanest container possible.
Yeah,
I definitely would. I guess the reason that I try to bring up the fact that older layers are still there is for things like if you do an npm install and it required you to authenticate, and so you have credentials being loaded into your Docker build. If you don't remove those credentials in the same layer, or if you aren't using something like the, I forget the new secrets method, I think secret mounts that you can do for temporary secrets, right? If you don't do it the right way, you can end up with credentials in the image.
Yeah, that's true. So to that end, I think one of the things that I want to suggest to anybody is that, I'd even say this is a benefit. With when it comes to Docker containers, it's really easy to start with any existing container. So having a 2-step process where you first build your base container that might have all the common libraries that you have across your entire organization and have a super slimmed down operating system and is just the base, right? You push that out, and then your other containers, including, the other containers your CI/CD pipeline are going to build off from, right? They're going to use that as the starting point. Have your developers also use that as the starting point. That way, they're starting from the same place as what is going to go into production. And so you kind of get those optimizations distributed everywhere. You know what I mean?
Yeah. Tom, did you have any comments or questions?
Yeah. I kind of want to bring up something that you mentioned about emulating the local development, but it's actually running in the cloud. I haven't done it too much, but I have more of a serverless background, and that kind of is a trend / best practice, right? When the code you're updating, as soon as you hit save, it's updating it in the cloud and running it up there with the same permissions, the same networking that's, emulated the same that it is for production. So you get that it's almost exactly like it would be in production. You're not, you don't have to mock out those API calls and things like that. What are your thoughts on that? And how is that common in the Docker development community?
Yeah, I would say it, classic answer, it depends.
Yeah.
But I've definitely seen where it's kind of a more, we'll say it's a more legacy pattern, a legacy architecture where you have things like big, expensive databases that you're running against. That's something where maybe even in the cloud, you have different tiers of functionality where you have like an ephemeral environment where it's running databases in a container. But then by the time you go to production, it's, a big fat RDS instance that's costing a lot of money.
Mm-hmm.
Now, if you design from the beginning for the type of flow you're talking about, I think that could be a more realistic feel and could be just as beneficial. But I think you really have to take some of those considerations from the beginning.
Mm-hmm.
So I'm going to say it's not common to have this kind of thing, but that's because the tools are still being developed like right now, right? But there are tools out there to connect to your container that's running in a Kubernetes cluster, for instance, and do exactly what you're talking about. I develop locally on my file, and it automatically gets shipped up and is now running in that Kubernetes cluster, which is running in AWS, which is connected to the development database and not just my local development database, right? That can be really powerful, right? Is the moment I'm writing that code and now it's live and up and has a URL that my client success team can go to. And it's not just on my local machine, right? Or the data, just having the data there sometimes can be important because, if I'm setting something up, I mock out my data locally. Now I want another dev to work on it. Well, now they have to mock up that data locally. If I could just mock it up in the dev database and we all have access to it, that could be a time saver, right? That can facilitate pair programming and all those great things that we all want to do. So having those tools available, I think, can be really, really powerful. I don't think a lot of people do that because I think it's kind of it's an older concept, but it's newer technology enabling it.
Yeah. I think of it the same way, right? Like back in the day, you're kind of making changes, right on the production server, but that was like the no. But now it's like you can have a production like infrastructure environment now with the cloud, right? It can be ephemeral.
Yeah.
So now it kind of comes back of, okay, yeah, I can develop right on that dev machine. It's not touching production, but it's, I'm making those changes and I'm seeing it exactly how it would run. I think it's a little bit more common too with serverless because the permissions are a bigger thing, right? Like what has access, those IAM roles and permissions where it's really hard to emulate and leveraging, if you're in AWS, all of their services and how they interact. It's very hard to mock out, and it just becomes a lot easier to develop right in the cloud. So.
Yeah, one of our goals, we don't have this built today, but we have a vision of what we want, which is I can create a branch of like a dev branch on our app repo, and when I push, it builds it and throws it on our Kubernetes cluster, and it's live. And when that branch gets deleted, it cleans it out of the cluster. And that simple thing we think will help with all of these scenarios, right? Like I don't have to have my dev here with their laptop and opening up their networking and, getting that all work out and DNS on top of that. Like none of that becomes a concern. It's just all automated on the Kubernetes cluster, just like everything else. And the crux of how we can possibly make that happen is because we've bundled everything into a container. There's just no other way, right?
Yeah. I think it comes down to, like Brendan said, with, it's, it depends. Right. It all comes down to the speed and cost, right? If you can emulate production and it doesn't cost anything, right? It's all usage based pricing, then it's great. You can have those ephemeral environments, have them up and running. But it depends on your architecture and the culture, like you mentioned. That's a big thing, how the company is ran and how they develop it.
Yeah. And I think we've had some really good discussion here. And if I kind of recap some of the things, we talked about the benefits of running containers in production, giving you the resource utilization and the way to deploy the dependencies and the code all at once. We talked about locally how you can get the very quick way to get up and running without having to install a bunch of stuff, just run the container. And we also talked about some of the tooling ecosystem that we can leverage around vulnerability scanning and things like that, which is all really cool stuff. Definitely, if people want to learn more about containers, I'm sure they can reach out to any one of us here or post questions in our Great Lakes Tech Leaders Discord server.
While I'm here, if you want to talk about containers, we're going to be having lunch on Friday. You could come out to that too.
Yeah, and if you're listening to this and not part of Great Lakes Tech Leaders, make sure to join. You can find it LinkedIn and the Discord channels where we're.
And so at this time, I want to thank all our listeners for tuning in to today's episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable. We would love to have you join us again for our next episode, which is going to have Lancelot Carlson and expert co-hosts discussing the fundamentals of generative AI. Should be really interesting conversation. So be sure to tune in to bridge the gap between complex tech and everyday curiosity. Thank you, everybody.
Thank you.